Okay, so one of the most important part of a software development, of course, is the requirement analysis and specification. Okay, so the requirement analysis and specification phases start after the feasibility study stage is complete and the project is financially viable and technically feasible. So the requirement analysis specification phase ends with the requirement specification document has been developed and reviewed. Then the requirement specification document is usually called the software requirement specification document or SRS. So the requirement analysis and specification activity are usually carried out by a few experienced members of the development team, and it normally requires them to spend some time at the customer site. So it is important for us to visit the company or our target clients, no, to interview them and to ask what are really need, what they are really need actually, no. So let's say, for example, the software engineers or the programmers who gather and analyze customer requirements and then write the requirement specification document are known as system analysts, no, in a software industry. So the system analysts collect data about the product to be developed and analyze to collected data to conceptualize what exactly needs to be done. After understanding the precise user requirements, no, the analysts analyze the requirements to weed out inconsistencies, anomalies, and incompleteness. So we can conceptually divide the requirements gathering analysis activity into separate tasks. Number one, we need to have a requirement gathering, and number two, requirement analysis. Now, in requirements gathering, again, it's too important, no? Please listen carefully, no? In requirements gathering, it is also known as requirement elicitation. So the primary objective of the requirements gathering task is to collect the requirements from the stakeholders. Let's say, for example, do they need a reservation module? Do they need a database module? Do they need a generation of reports? Do they need, let's say, a security, of course? Do they need audit trail? And so on and so forth. Now, the customers or your client usually provide a statement of purpose, no? Document to the developer. So typically, these documents might discuss issues such as the context in which the software is required. So again, as I mentioned earlier, it's too important for us to have an interview. Typically, there are many different categories of users of the software. So each categories of users typically requires a different set of features from the software. Let's say, for example, you are looking to create a SIS, no, Student Information System. So therefore, you are required to have an account for the administrator, account for the registrar, account for the student, account for the parents, and so on and so forth. So therefore, it is important for the analyst to first identify the different categories of users and then determine the requirements of each. So of course, there are certain activities or transactions that you were not able to manipulate with this account. There is certain restriction. Okay? So another thing is the task analysis. Now, so the users usually have a black box view of software and consider the software as something that provides a set of services. So a service supported by the software is also called a task. So we can therefore say that the software performs various tasks for the users. Now, in this context, the analyst tries to identify and understand, no, that different tasks to be performed by the software. So for each identified task, the analyst tries to formulate the different steps necessary to realize the required functionality in consultation with the users. Again, so you need to ask what transaction to be done with this account, or what will be the common transaction do you need in your account, and so on and so forth. Then, number 4, of course, the scenario analysis. So, a task can have many scenarios of operation. So, the different scenarios of a task may take place when the task is invoked under different situations. So, for different types of scenarios of a task, the behavior of the software can be different. Of course, no? Then form analysis. So it is an important and effective requirement gathering activity that is undertaken by the analyst when the project involves automating an existing manual system. So you need to find out in manual process, what will be the step, what will be the procedures. Then this manual process, no, as a programmer, what you're going to do is to assign to make it computerized, of course. So during the operation of a manual system, normally several steps or several forms are required to be filled up by the stakeholders. And in turn, so they receive several notifications. In form analysis, the existing forms and the formats of the notification produced are analyzed to determine the data input to the system and the data that are output from the system at the same time. Now, for the requirement analysis, after requirements gathering is complete, the analyst or the leader analyzes the gathered requirements to form a clear understanding of the exact customer requirements into without any problems in gathered requirements. It is natural to expect that the data collected from various stakeholders to contain several contradictions, ambiguities, and incompleteness. It happens. So the main purpose of the requirements analysis activity is to analyze the gathered requirements to remove all ambiguities, incompleteness, and inconsistencies from the gathered customer requirements and to obtain a clear understanding of a software to be developed. So during the analysis, the analyst needs to identify and resolve three main types of problems in the requirements. So number one, anomaly. Number two, inconsistency. And number three is incompleteness. Now, when we say anomaly, it is an anomaly, is an ambiguity in requirement. So when a requirement is anomalous, several interpretations of that requirement are possible, and any anomaly in any of the requirements can lead to the development of an incorrect system, since an anomalous requirement can be interpreted in several ways during development. Number two is inconsistency. Two requirements are said to be inconsistent if one of the requirement contradicts the others. Or maybe the registrar's account saying that they need this one. It must not be shared with accounting department. But the accounting department said the registered account must share this account. So there's certain conflict, right? So the lack of this feature should be felt by the customer much later, possibly while using the software. Often, incompleteness is caused by the inability of the customer to visualize the system that is to be developed and to anticipate all the features that would be required. Okay, so I just want to play a video, for as an additional input, for this discussion. So if you have some additional question or inputs with that discussion, do not hesitate to post your question to our chat box. Okay, so this will be an additional discussion about the requirements analysis during software development. Specifically, actually, in software engineering, you are required to develop a software. Again, in thesis, you are not obliged naman to develop a software, provided that you are going to prove something like an algorithm, but as what I observed with your proposal, majority, actually not all majority, but all of the groups wanted to develop a software. That's why we need to consider the software development, and the requirement analysis and requirement documentation must be considered. Okay?
Video tutorial is on software requirements analysis, and in this video, first of all, we are going to look at what exactly are requirements, so that we are able to understand what requirements really are in the context of a software project. Then we look at the different types of requirements, and then we look at other sources of requirements in case you do not have the software requirement specification with you. Then we look at examples of how you can analyze the software requirements given to you to find out the problems with those software requirements. So let us get started. First, what is a requirement? A requirement of a software system is a functional or non-functional need that's to be implemented in the system. So functional may mean that if it is a system that provides some kind of service to a particular type of user, so what kind of service will it provide to that user? For example, in the context of education, it can be a requirement saying that when the student looks at their profile, they'll be able to use the system to look at their existing profile information. The software requirement can also be a non-functional need in the sense of it can be a performance requirement. So there can be a non-functional need that every page of the system should be visible to the user within 5 seconds. So basically, a software requirement is a functional or a non-functional need that needs to be implemented in the system. Software requirements are usually expressed as statements. So each requirement is expressed as a statement. In order to clarify the requirement further, there can be an example given with the scenario that gives more details of how exactly the requirement is supposed to be implemented in the system. Now let us look at different requirements types. First of all, we have the business requirements. Business requirements are the high level requirements that are taken from the business case for the project, and we'll look at examples of each type of requirements. More detailed are the architectural and design requirements that show the overall design required to implement all the business requirements. And the most detailed are the system and integration requirements. System and integration requirements can appear in the form of system requirement specification, which is the detail of each and every requirement. And it can also come in the form of user stories, which is really describing the requirements in everyday business language. So let us see examples of the three types of requirements. So first of all, let us look at a business requirement. So this is a sample business requirement document that I have taken from the web. So as you will be able to see that it is a very high level kind of a document containing high level requirements. So let us see few examples from here. So it gives the overview, etc., and this is a section where it gives the requirements. For example, section 4.1 of this sample says that there is going to be a banking services system. It's provided for 4 Asian countries in the Asia Pacific, and the names of the countries are given. Then it just says that in which country, which major functionality. For example, in Singapore, account summary and fund transfer functionality will be available. In Malaysia, account summary and bill payment functionality will be available. Other high level requirements can appear in this business requirements document. The master customer information will include all these elements for a new mobile internet user, like a unique user banking ID, bank branch, full name, etc. So this is a high level kind of a requirements. This is an example of the architectural requirements. So these are more detailed than the business requirements, but still they are at the architectural and design level. If you have not viewed our vModel tutorial, please view that so that you are able to understand these things in more detail. So this contains the use cases. So the major use cases in the architectural and design requirements are given over here: login, register for courses, maintain student information. Obviously it is related to an educational system. So let us look at a few requirements. For example, we can see the login use case. The brief description is given. This use case describes how a user logs into the course registration system. The actors starting this use case are student, professor, and registrar, which means that the login functionality in the system can be invoked by a student, a professor, or a registrar. At the lowest level, we have the system and integration requirements. This is an example of the system requirements specification. So this is given in very great detail so that coding can start from here. So here it says, for example, student self-service is the module, and the student can make changes to his or her courses, and the personal profile of the student will contain the student address, their student authentication, that is PIN, their email address, fax address, and stops, etc. For registration, they have to give registration status, course status, current schedule, register for a course, add or drop a course, etc. So this is in the most detail. Now let us move on. Now sometimes if you're working in a project, it is possible that you do not get any requirements documentation to work with, but still there are other sources of requirements, and before you start your software development or testing, you need to gather the requirements information from these other sources so that you can base your software or base your test design on these requirements that you gather from the other sources. First of all, it's a knowledge transfer. So if you are new to the team, the existing team members may already be aware of what are the requirements they are working towards in implementing in the system, so you can get a knowledge transfer from those. You can always talk to the business analyst, product manager, developers in the project, project manager, or the client to get what are the main requirements and to get some details of the requirements. Then you can also analyze the previous system versions, work with them to understand what is the requirements that are already implemented in the system, so that you have a familiarity with the existing requirements. It is possible that there are older requirements documents available, and you can look at those along with the previous system versions to come to know about the existing requirements already implemented in the system. Then you can also look at the past bug reports. Some of the bug reports are turned into enhancement requests which may be implemented in the current release of the system. You can get information from those. You can also look at the install guide if it is available to see what are the existing installation requirements. And finally, you can leverage your existing domain or industry knowledge to understand what the existing system is all about and what is the new requirements that the team is trying to implement. Whatever requirements you get from these other sources, make sure to document them in some form and get them reviewed from the other knowledgeable team members so that you have a good idea of what is the current overall set of requirements, including the previously implemented requirements and the new requirements that the team is working to implement in the system. And then there can be legal or statutory requirements that every system in that category has to implement. Now let us look at how to analyze the requirements, and let me jump into an example over here. So here in this example we have 3 columns. First is the requirement quality. When you look at all the requirements, whether you have got the requirements from a requirement document like a software requirement specification or architectural requirements document or even business requirement document, or you have gathered your own requirements, you need to look at different qualities of each and every requirement. The next column is example of a bad requirement with some problem, and then the same requirement converted into a good requirement once the requirement problem is removed. So each and every requirement that you have should be atomic. Atomic meaning it should be at a very low level of detail. It should not be possible to separate it out into components, because requirements have to be kept simple if they have to be implemented completely and correctly without any confusion. So example of a bad requirement is, let us continue with the example of a system being developed in the education domain. So students will be able to enroll to undergraduate courses and postgraduate courses. This is not atomic because it talks about two different entities of the system, undergraduate courses and postgraduate courses. So obviously it's not a good requirement, it's a bad requirement. The corresponding good requirement will be to separate it out into two requirements. So one just talks about enrollment to undergraduate courses and the other talks about enrollment to postgraduate courses. The next requirement quality that each and every requirement should have is that every requirement should be uniquely identified. So here we can see that there are a couple of requirements: enrollment to undergraduate courses and enrollment to postgraduate courses, but the ID given for both is 1. So which means that if we are talking about a particular requirement ID of 1, it is not clear which exact requirement we are referring to in other documents or parts of the system. So separating it out with unique IDs, so the requirements can be rewritten as the section 1 is course enrollment, and it has two requirements. 1.1 ID is enrollment to undergraduate courses and 1.2 ID is enrollment to postgraduate courses. Then each and every requirement should be complete. Here is an example of a bad requirement. It says a professor user will be able to log into the system by providing his username, password and other relevant information. Well, what is the other relevant information? So it is not clear. So when that other relevant information is spelled out so as to completely flesh out the requirement, it becomes a good requirement. A professor user will log into the system by providing his username, password and department code. So this contains all the information. Then each and every requirement should be consistent and unambiguous. So here, for instance, we have a requirement: a student will have either undergraduate courses or postgraduate courses, but not both. This is one requirement. And there is some other requirement which says some courses will be open to both undergraduate and postgraduate students. The problem here is that a student can either go in for undergraduate course or a postgraduate course, but not have a mix of both, which seems to indicate that the courses are divided into two categories. Undergraduate courses are separate and postgraduate courses are separate. But the other requirement seems to say that some courses are both undergraduate courses as well as postgraduate courses. So obviously there is a conflict over here, and this needs to be resolved by whoever is documenting the requirements. So converting it to a good requirement can be just removing the other conflicting requirement. So which says now a student will have either undergraduate courses or postgraduate courses, but not both, which means that every course will be marked as either being an undergraduate course or a postgraduate course. Then each and every requirement should be traceable, because there are different levels of requirements. We already saw that at the top we have the business requirements, then we have the architectural and design requirements, and then we have the system and integration requirements. Now when we convert business requirements to architectural and design requirements, or we convert architectural and design requirements to the system and integration requirements, there has to be a traceability, which means that we should be able to take each and every business requirement and map it to the corresponding one or more software architectural and design requirements. So here is an example of a bad requirement. It says maintain student information is mapped to BRD, requirement ID is not given over here. So converting it to a good requirement, it says the same thing, maintain student information, and it is mapped to BRD requirement ID 4.1. So there is a mapping should be present for each and every requirement. Same way we have mapping between high level and low level requirements. The mapping is also there between a system and integration requirement to the code that implements that requirement, and also there is a mapping between system and integration requirement to the test case which tests that particular requirement. So this traceability is all across the entire project. Then each and every requirement should be prioritized, so the team has a guideline, so which requirements they need to able to implement first, and which can be done later on. Here an example of a bad priority, you can see register student, maintain user information, enroll courses, and view report card. Each and every requirement is given at priority 1. Each and everything cannot be at the same priority, so the requirements can be prioritized. Now this is an example of a good requirement. We can see that registered student and enroll courses at the highest priority, maintain user information comes below at priority 2, and then we have the view report card. Then each and every requirement should be testable. An example of a bad requirement which is not testable is each page of the system will load in an acceptable time frame. Now there are two problems with this requirement. First is that each page, meaning that there can be many pages, there can be many different pages. So first of all, it just is going to blow up the testing effort that is required, because the system may have thousands and thousands of pages. The main problem with this requirement is that it says each page of the system will load in an acceptable time frame. Now what is acceptable time frame? Acceptable to whom? And people can always argue that this is acceptable or this is non-acceptable, because this is not objective or specific time frame given over here. So this requirement is not testable. So we need to convert a non-testable requirement into a testable requirement. So here is the example of the good requirement. So it specifically says which pages we are talking about. So we are talking about register student and enroll courses pages, and the acceptable time frame is also given within 5 seconds. These two pages should always load within 0 to 5 seconds. So this is how we have to look at each and every requirement at the appropriate level. For example, if we are going to build the software with regard to the system and integration requirements, we have to look at the system and integration requirements given in the software requirement specification or the user stories, and apply this check to each and every requirement. That each and every requirement should be atomic, uniquely identified, complete, consistent, unambiguous, traceable, prioritized, and testable. Same thing goes when we have to do the test design, create the test cases. Again, we have to look at each and every requirement given in the software requirement specification or the user stories, and apply each of these checks to make sure that the requirements are uh, good requirements. They satisfy all the good requirement qualities. So I hope you were able to understand how to understand the software requirements given to you,
Okay, so again, the discussion is all about on how we will be able to consider the software requirement analysis. So this time, how about the software requirements documentation or the software requirements document? No, so a software or a software documents or a software requirement documents or software requirement specification is a documents that describe the intended use case, features, and challenges of software application. And these documents are created before the project has started development in order to get every stakeholder on the same page regarding the software functionality. So software requirements documents provide an important map of the product being built and the features that will be included, and of course, much more. Now, in software development, the roadmap helps to keep the technical and non-technical teams on the same wavelength as to what the expectation are. So it helps to ensure that the product is built meeting the needs, whether it's for internal purposes or for the use of the clients. No? So for the software requirements, we need to consider the introduction, the purpose, the intended audience, the scope, of course, the definition and acronyms, the overall description, user needs, assumption and dependencies. And when it comes to system features and requirements, as our video mentioned earlier, we have the functional and external interface requirement with the system features and non-functional requirement also. So I'll just show you a video regarding the software requirements or requirement documentation.
In this particular video, we will be discussing about another topic that is a software requirement document, which is very popularly known as SRS, that is software requirement specification document. So this is one of the very essential document that every software industry is going to prepare whenever they will come up with to start a new project or new software development is concerned. Okay. So normally this SRS, software requirement document, is an output of our first stage of our software process activities, that is software specification. So once you are going to complete 100% defining all the requirements like functional requirements, non-functional requirements, then all the domain requirements. So finally you are going to come up with this particular document, and that document is called as what? Software requirement document. Okay, and this will be acting as an the main source and information related to the overall project is concerned, and most of our the rest of the part of design, implementation and testing, this particular document is going to be act as a very important input source. Clear? So let's have a discuss about this particular document and its structure. Okay, so the software requirement document. So the first point is the software requirement document is the official statement of what is required of the system developers. So basically the are going to depend on this software requirement document. Okay, so every requirement in detail with technical perspective along with the necessary diagrams and each and every related information, every requirement will be defined in this particular document. So which will be helpful for all the system developers to design and implement the actual functionalities and services that we are expecting from the software to be get developed. Okay. So the second point is it should include both the definition of user requirements and a specification of the system requirements. So both user requirements and system requirements will be clearly defined in this particular document, and it is not a design document basically. Okay. So as far as possible it should set off what the system should do rather than how it should be done. Okay. So here we are giving the importance for what should be what my software is supposed to do here. But okay, so the document is not going to focus on how it should be done. Okay. So coming to the next point, so just have a look at there. There are variety of users for whom this particular requirement document will be very much useful, especially for the system customers, because they will be the end users who are supposed to use this particular software. So, for them it will be helpful to read and check how exactly their needs will be get matched, means fulfilled after development of the software is concerned. For that, it will be helpful for the system customers, and the same document will be helpful for managers. So, managers in the sense it will be helpful for them to plan and for bidding, for contract purpose, okay, for financial aspects, and to monitor the overall system development process. For all these things, for the project managers are concerned, this document is very much useful. And for the system engineers, the system engineers means the people who are involved in the overall design and development of the overall software. Okay, for them, so this is very important document, because it will help them to understand what exactly the requirements that user is expecting, and what is to be get designed and developed. Okay, so that they will come to know only after referring this requirement document. Okay, then for system testing engineers is concerned, okay, for them also this particular document is very much useful input, because system testing engineers are responsible for performing the validation. Okay, so validation is nothing but what? Testing. So, either it may be system testing or acceptance testing. While doing all such kind of variety of testing, for all the testing engineers, this requirement document will be acting as a input. Okay. So, because when they will test the system, they will come to know that whether the requirements in terms of services and functionalities have been correctly implemented or not. So, that is possible for them to check with the help of this document as an input. Okay. And finally, for system maintenance engineers also, this document will act as a very important source to understand how the system has been developed earlier, and what about the relationship between the different parts of the system. So, it will be helpful for system maintenance engineer, because normally what happens, once the software is get developed and it will be get deployed for the end users, so automatically the problems will arise. So, at that time the software has to undergo maintenance or evolution or modifications. So, at that time the people involved in that maintenance will be separate. See, normally the maintenance engineer will not be a part of the development team. Okay. See, most of the time what happens, software will be developed by somebody else and it will be maintained by somebody else. But whenever as a maintenance engineer, if he is supposed to make some corrections or some modifications or some servicing or any kind of the problem solving is concerned with that particular software, then he should also know that how exactly the system was developed. Okay, what are the actual original requirements. Okay, so every knowledge that person should have, and this document will help that maintenance engineers to understand about what exactly the system was in the beginning. Clear? So, in this way this document will be helpful for the different sort of users, means the different variety of stakeholders who are directly or indirectly involved in the software development is concerned. Okay. Now, the very important topic, just have a look at there, the structure of this requirement document, means with what structure this requirement document is to be get prepared. So, it is just like as if you think of a report or just like a textbook, or it is just like a one big book, a Bible, that they are going to come up with this document here. Always do remember. Okay. So, it's a very big document in which a detailed information about the whole software project which is to be get developed, that everything will be recorded over here, along with each and every requirement which has been defined as a part of that software development. Is it clear? So, that is why, just like as if whenever we will look into any textbook, every textbook is having its own structure. Okay, there will be the content, then there will be an abstract, introduction, then chapter. For every chapter there will be a summary, then questionnaires, okay, index, appendix, see there. So, just like the structure of whatever may be the textbook that we might be applying, the similar kind of a structure that we need to adopt for writing this or preparing this requirement document is concerned. Okay. So, there are different chapters that we need to include here. So, just have a look at there, we will go one by one very briefly. The first chapter of my requirement document should be a preface. Okay. Normally this preface is going to contains, so here we are going to define the expected readership of the document, means for whom this document has been kept. Okay, and what is the purpose of this document, what are the objectives, and about their history, and any previous version which is related or any new version which has been get released. So, everything will be get recorded over what in the preface. Why? Because normally every time when my software is undergo evolution or modified, whenever the software will come up with a new version, automatically this document will also be get updated. Normally that you might have observed in textbooks editions. See, for example, say whenever they are going to release for a new edition, say some 9th edition of software engineering, then automatically in the preface they used to mention what are the changes that the textbook has been made from 8th edition to 9th edition. What are the new additions have been taken place, what are the new chapters, new concepts. So, similarly here also that preface is going to contain all these things. Then the second chapter is introduction here. So, introduction part we are going to describe the need for the system or that need for the software. So, what purpose the software is going to be get built, and also we will be describing the system functionalities. Okay. So, briefly how they will work with other systems. Why? Because we have already told software is not an independent component, it should work along with the other supporting applications, either it may be another software or it may be another hardware. So, that everything will be get explained over here. Then the third chapter is glossary. So, here we will be defining an important technical terms which are used throughout this particular document is concerned. So, that you might have observed in most of the documents and textbooks also. So, the important glossaries means the wordings that will be get defined over in the very beginning itself. Okay. Then coming to the next chapters. Okay. So, the next chapter is user defined requirement, means user requirement definition that I have already discussed. So, here it consists of the services that should be provided for the user by the software at the abstract level. Okay, that will be get defined in their own natural language and with the help of some diagrams or any kind of notations. So, all the user requirement definition will be done over here in this particular chapter. Then a system architecture will be get defined here, and high level overview of diagrammatic representation where the system is going to be get shown along with its different parts. Why? Because once again the same thing, the software is not a single entity, a software is made up of different parts there, or any system is concerned. Then every part of the system is to be get shown, and their relationship that we can exhibit by drawing this system architecture or defining this system architecture. This should be a separate chapter. Then system requirement specification. See there, all our abstract level defined user requirements should be written under what? The system requirement specification, which are going to describe here. We will be defining the classification of the requirements like functional requirements, non-functional requirements, okay, and their details, everything, okay, and even the interface between one part to the another part, means they are called interface relationships, that requirements. So, there are variety of requirement classification will be done over here, and that will be defined in detail, and these system requirement specifications are going to be very much helpful for the system developers. Clear. So, then there will be another chapter called a system model. System models means actually these are the graphical representations here. So, here normally what happens, whenever I will define the variety of functional and non-functional requirements in terms of system requirements. So, every requirement should be get supported with some graphical notations, that is graphical system models. So, which will helpful for the developers as well as the users and managers for the better understanding of how the system should be get developed. Okay, what exactly the system working nature. So, that will be very much helpful for to analyze and understand the system in a better way. So, okay. So, there are variety of different graphical representations are there, especially they are called UML diagrams also, like the object models are there, data flow models are there, okay, activity diagrams are there, subsystem models. So like that there are variety of different system models will come across, that we will be studying in a separate chapter, okay. And even if you try to recall in our insulin pump structure, that example case study, we discussed one activity diagram there. So how exactly that insulin pumping system is going to work, okay. That is one type of diagram which will depict that how exactly that particular system is going to work. So similarly here also, that is the usefulness of what, the system model. System models will always helpful for the better understanding of the requirements, and always do remember one thing, okay. A picture is worth more than 1000 words, always remember, okay. Rather than simply explaining the things in terms of paragraph or in some language in written format, if you show it or with the help of some diagram or picturization, so it will be more effective always, clear. Then the next chapters are that is system evolution. So it will be a separate chapter. So here we are going to describe about the assumptions on which the system is going to be based, and tomorrow how the system is going to be get evolved or what, changed. See there, till now actually the system is not yet developed actually, but before the development of the system itself, you should have a well planned and your assumptions. Tomorrow if you develop this software, okay, then when it will be get evolved and how it will be get evolved and because of what reason, that imagination you should have, okay. So that should be get explained under what, the system evolution is concerned. Then last but one chapter, that is appendix. So you know that as usual in most of the textbook also, so sometimes the appendix always consists of some supporting information which will be helpful for the understanding of the actual content of the document. So that will be covered under what, this appendix. So in case of the requirement document is concerned, sometimes we may need to understand more about the other softwares and hardware devices, their description. So all these things will be, and even database description, is it clear, hardware requirements. So all such extra information which are needed, that will be covered under what, the appendix is concerned. And the document is going to be ended with the last chapter, that is index. So index consists of what, there are a variety of indexing method that you can use. So there are several indexes to the document may be included, either it may be a normal alphabetic index or a index of diagrams or index of what, the functions. So like that, as per your requirement, you can put that index which will be helpful for the user to search for a specific topic and any keyword is concerned, okay. So these are all the different chapters that should be get included as a part of what, the structure of software requirement document, which is very popularly known as that is SRS, okay. So please do remember this the overall structure of that SRS. Thank you.
Okay, so I think that's it, no? In software requirements, in documentation, specifically in chapter 2, you need also to consider what are the software requirements. Let's say, for example, you are going to use, let's say, PHP for web, or if mobile, you are using SQLite as your database. For operating system, you preferred, let's say, for example, is let's say Windows 10. Let's say, for example, for let's say that is website, you are very particular with Google Chrome or with other web browser and so on. And at the same time, we need also to create our what do you call this one? tools, no? Let's say, for example, during your system analysis and design, we are using waterfall model, no? But this time, we were looking forward that you will be able to use an agile, no? Either B model, RAD, JAD, and so on and so forth. Okay? So I think that's it for this topic.